Hello. So, welcome to this course on spatial informatics. Today, we will be having a broad view of that what we mean by spatial informatics. Rather, for many of you, it may be a new course or new terminology, though we are accustomed with different aspects of spatial data sets these days. So, when we talk about spatial informatics, more specifically we will be dealing with geospatial data, that means data related to earth surface. This has a different implication. If you look at our all type of data sets what we deal with for our day to day activities at commercial level, at different aspects of decision making, you say there is a little bit of reference to the earth surface. Like think about say a student database, it says that which hall he or she is there, which is the department he or she is studying at. That means, it is relating it with all other different type of attributes to somewhere putting to the coordinate, even if we look at the home address and all other things, right. So, that means, it makes lot of sense to look at this, how these data sets related to earth, what does it mean and type of things, right. So, this course primarily hover around these aspects of the things, though truly speaking spatial in a sense can be anything on the space, right. It is not only our mother earth, it can be on a universal level. Even if I talk about a body as a space, then also there are different location, right, like eyes are in some places or location of a heart is in some places and etcetera, etcetera. But we will be mostly concentrating this particular course on the data sets related to earth surface. Why it is so important, why we require a separate way of looking at these spatial data sets or spatial databases, that we will see over few lectures, and I believe you will appreciate that there is a need for have a separate dealing for those type of things. If we look at this different aspects, like if we look at that what are the different application areas which will be looked at. So, it is a first of all it is a emerging field, it is for say 1 decade or so, it has came up in a big way, and maybe due to use of maps for finding routes from finding a one location to another locations, those are more popular, becoming more popular, and it became a more popular for our day to day use also. Not only that, with recent or over this advancement of computational resources, that means availability of huge computational resources as a much lower price, this data intensive, compute intensive, this sort of domains has become more popular or becoming are more popular. So, if you see these has wide scale application in different natural different domains, right. One is definitely natural resource management, right, like I want to find out that how this my forestry coverage or how much coverage of the forest is that, whether it is how it is changing over time, or say in aspects like any type of disasters like a cyclone or flood, or even a very man-made disasters, or like maybe a fire broke out and type of things. We do not need to know that what is my overall resources position and type of things, right. So, it and has a wide scale application in natural resource management, not only that, agricultural production estimation. So, it is a huge data to be churned in and type of things, which has a relations with space or a earth coordinate. And in some of the cases we will see later on, it is not only space, it has a relations with the space and time, how things changes, like climate change, how climate change is going on, how things are affecting and type of things, right. We will see. So, there are application in smart city applications like finding, as we are discussing, that we do day to day, finding a particular path or between point A to point B or shortest path, minimal time, or sometimes with different other parameters and type of things. So, it has a smart city. There are several aspects of smart city applications which helps us, which needs space time informations. One is transportation challenges, there are challenges of maintaining public health, or even how overall say pollution map, how things are evolving over time and type of things, all those things are there. Whether I can make smart city, intelligent cities where this sort of information become a major aspect, or maintaining this type of information is a challenge. And of course, we kept this intelligent transportation as a separate head, because the transportation has a huge applications. We will see some use cases how things can be there. We are used to several type of aspects like with car sharing, different type of finding a minimum path and type of things. And not only that, whether I can do some of the intelligent type of, whether there the traffic lighting can be made intelligent or making made more amicable with the crowd. And you see the one of the major problem with large cities are there is a volatile population, a huge amount of people or population come push into the city during the morning hours, which goes out of the city, or a big portion goes out of the city in the evening hours. Now, for this the whole dynamics go for a hayway, right, or we need to learn. Rather, there are work which tries to learn a typical dynamics of the cities, right, which may help in overall traffic management in a particular city. So, that means intelligent transportation is one aspect, environment and climate change monitoring is another aspects which are extensively important and being used. And there are development planning activities like say government things that have different type of development planning activities or schemes, how they are performing, because there is a public money which is being invested, how they are performing, how much of the population is getting benefited, and how to some sort of quote unquote audit them, that what is the, how much has been invested and what is the overall return on the things, not only on the work front, on the socio-economic front and other things. So, what we see that these aspects, it is not only data related to earth comes into picture. So, whether it is necessary or it makes more sense if we try to look the data in that perspective, right. How do I represent, like how do I represent say this campus, IIT campus on a map, how do I analyze the map, how I can basically mine a map or such data, right. I want to mine the data for last say 10 years, 20 years and find out and try to make a predictive or forecasting model to see that what will happen next. So, definitely it involves acquisition and analysis of data related to earth, commonly referenced as geospatial data set. So, spatial data and geo is primarily related to the earth. As I was telling, the spatial data can be anything on the space, but if we talk about more on our earth, so it is geospatial data sets. And we will see that it is a multidisciplinary activity. It requires several disciplines. First of all, if we look at any portion of the earth, so if you see what are the things are there, if we commonly we say that how the land use is there, right. Say consider our IIT campus or any campus or any city. So, what one is that road network, right, which may be a transportation, which is under maybe a separate department or under civil engineering. There are things which are what sort of vegetations are there, what sort of build up areas, what sort of soil structure, what is the population map, and anything like how what is the air pollution and so forth. In other sense, if you see, there are different domain coming into picture. What they are pinning to is to a particular location, right. It is IIT campus, this portion of the IIT campus, or this is a city in Delhi or Kolkata, this portion of the city area, right. So, that is, it is a multidisciplinary, where if you see, computer science principles, algorithms are increasingly applied to address various challenges and problems of this type of large scale data sets. It is a huge data sets, it is enormous data sets. So, these are where we computer science, IT related expertise needs to be applied to find out meaningful information out of this data set, right. So, here we come into picture. So, in this course we will try to look at those aspects, right. What are the aspects, how data need to be modeled, right? How to model a campus, how do I query something, whether our standard database query system will work, or whether we require some sort of a special query type of engine, whether how to mine this data. So, representation, acquisition, representation, mining things are what we try to look at. We will see that there are other several different challenges which coming into play, which requires this our so called CS knowledge or CS different principles need to be applied. So, that we talked about. So, there are different aspects of spatial informatics, which some of them or several of them will be trying to address in this particular course. One is spatial data models, right. How do I model a spatial data, right. Modeling a non-spatial, so called non-spatial things may be one aspect that is also important, and that some of you or many of you may be knowing, but whether there is a speciality of modeling spatial data, right. So, and whether there is how this spatial database looks like. We are used to that DBMS or RDBMS, relational database models, which are widely used, whether the spatial DBMS, how they differ from this our standard database, or what extra is there into the thing, right. Then of course, spatial computing, right. I want to find out, say what is the if there is a say this particular river is flooded, how much area is likely to be affected, how much crop is likely to be inundated, right. What should be my plan of relocation this population, how much population is there. That means, there is a good amount of computing is necessary. One is that querying and retrieving the data and computing the things, and so one is computing, another is analysis of the data, like I want to do a multi-layer modeling of the different aspects and find out a analysis, and of course, mining the data, right. With our standard data mining techniques definitely are used, but whether we require some special attention to the spatial aspects. So, spatial computing, spatial mining, spatial data analysis, this is becoming popular. Rather, these days we see the word which is the jargon, or which is more coming up, encompassing all those things, or maybe interchangeably used in number of places or number of cases, is that spatial data science, right. How to address this huge large scale data into the things. Another aspects of this is geographical or geographic information systems, right. So, it is an information system like any other information system, right, library information, which look into the geography of the earth and allow you to work on it, right. It takes care that the database models are there, right, and with that we can have a geographic information system to find out different queries or find out different inference on the data sets, right. We will look into those aspects also. Another upcoming area for quite few years is the spatial web services, right. So, whether I can give as a services, we are used to that, right. I want to find a location A to B, I do not have to download the data set, look into the map and find out, right. Previously, say long back, you need to buy the map and then find out which place to what. Now, we have a lot of dynamic things, right. So, what we are looking at is more of a web service related things, right, web services, right. We are used to that. We are used to say business services or say e-portal like your e-marketplaces, etc. Those are services, right, or buying tickets in airlines or railways, etc. Those are services. So, whether it is possible to have special web service? Yes, it is possible. We are knowingly unknowingly using it, and that will be a good aspect to look at. Like I have a services defined, then when I require, I call the services and look into the things, right. So, these aspects we will be looking into this particular course. So, if we look at this data sets, so this was my this down thing is my real world, right. It has city, county, city A, city B, county, etc. region wise, which are more of a administrative boundaries, which are not there actually out here. It is nobody has written, right. We say this is a state of West Bengal, this is a state of Maharashtra, state of Bihar, state of Odisha, these are administrative boundaries. So, this is a layer. So, there is a layer which I can take out this elevation, like elevation, you know that at which portion what is the elevation, we usually calculate with respect to the mean sea level, right. There can be a layer which is land uses, how the land use used, this portion road is there, that is a building is there, or somewhere vegetation is there, somewhere water body is there. So, this is how the land use land is used, land uses, or sometimes land use and land cover. So, how is land is used and cover. There are things called parcels, streets, and there are road networks also. So, there are what we say, though we have this is the real world data, I can segregate these different layers, right, use some or more of the layers to do some computation, spatial computation. Like I want to increase the width of a particular highway, say national highway, say national highway 6, we want to from 6 lane to 8 lane or 8 lane to 12 lane, so we want to make it. Now, the thing is that what should be the cut and fill, like how much area I require. So, that is the estimation. So, for that I require a road network, I require a that what is the land use, land cover of the things, and I may require some other aspects of the things, like if it is educational institute, a school, etc., I may not be able to break it. So, I may have a detour that government may have different type of policies. So, those things will be there. You see, so I need to do a multi-layer modeling and also based on different other constant, etc. So, this if I can extract this thing, this multi-layer and store somewhere, it may be possible for people or possible for decision makers to work on those things. So, what we are trying to this is I am trying to create a information base with a back end database, proper database models, and giving them connector as a special say services by which they connect and get the services, right, or they in the sense we will be working on those things, or it can be hooked into other systems to work on, right. So, data that pertains to space occupied by objects. So, geometric and varied. So, there are geometry aspect of the thing. Naturally, it is very high dimensional. So, different aspects like you see there are multi layers and type of things may associate with non-spatial attributes, like I say this is a road, there is a name of the road. So, that is a non-spatial attribute, right. Nowhere on the road it is written the name of the things, right. So, there can be, or this is a region, there is a name of the region, that number of say population count. It is difficult that from the things we can see that how many, what is the population density of the thing. So, population density. So, there are aspects which has some different attributes. So, examples of spatial data, one is the satellite remote sensing imagery. So, we get a huge amount of data from the satellite remote sensing imagery, our own IRS satellite, Indian remote sensing satellite, which captures data very frequently. So, there is a huge data set. There are weather and climate data which comes from different sources, meteorological offices like IMDs etc., and type of things, Met offices. There are census data which are collected at different point of time, that is the particular authority. It can, if we talk about the spatial data, it can be medical imaging data also, right, medical imaging of the body where it is also a coordinate. So, it is idea is that if I can put on a basically a graph paper, if I can find out that where this position is, that at that position what is the thing, right. So, in this particular course we will be dealing most primarily on geospatial data sets, data related to the earth, not on the medical imaging etc. Now, broadly see there are two terms, vector and raster was coming up, we will come to that, many of you may be knowing. So, broadly the data structure at a gross level is two things, one is the vector data sets and is the vector or is the raster data structure, we will see that. Now, before just what we are discussing, one is the information and the geographic position. So, it allows us to handle another separate set of information system which is geographic information systems. So, we will come to that aspects, already we were discussing, right, mean of storing, retrieving, sorting, analyzing spatial data to support some decision, there are two support. So, decision making processes. So, this spatial data again I must say that many of these images are taken from different internet resources, most of the cases, many of the cases I try to refer, otherwise it is absolutely for academic purpose we have I am using it. So, you see this is a data which has a attribute data, right, which is the different type of aspects of the things, right. So, this is data which is different description. So, this is a image, but which refers, this is a spatial image or spatial data which refers to different attributes of the aspects of the things, like it says that hard or paved way. So, it is not written on the things, right, it is a attribute to the things, we will come to those aspects. So, if we look at the spatial data sets, one end is definitely the database management system. Unless there is a strong database management system, handling data is a problem, whether it is spatial, non-spatial, anything, we require a some database management system, right. So, in order to handle that, we require the spatial data and attribute data. So, spatial data is the data which is on the, it can be seen, or very grossly telling, if I go little up in the over the earth surface, if we look at what is there, take a picture, what we see is the spatial data, right. It can be from the satellite, it can be from a drone, it can be from a balloon by which it can take a photograph, but what we see on the things, right. There are different challenges, we will come to those challenges. So, spatial data and the attributes. So, attribute is what is the meaning of the data. This is a road, this road is say IIT main road, it is not written on the when you take a picture, you have to give a attribute of the things, right. Even when we take the picture of our things, a group picture, then we have to say this person is this person is this is the attribute of the things, right. We say there are, if we on the broadcast, these are ladies, these are gents, this is putting attributes to the things, right. So, those are to be marked. So, one side we require a spatial modeling and the aspects of the things, other side finally we need to visualize that, and the visualization can be different aspects, like the way I need to see for my purpose, you may want to see the data in a different purpose altogether. I am a transportation person, I do not want to look at the road in more detail, other things are there. You are somebody maybe a say climatologist, you want to look at the climatic or weather conditions, right. Some may be water resources, but look at the water aspects of the things. So, the same data sets can be visualized in different aspects. So, if we come back, try to come back to the same thing. So, one is that this is our real world, we have seen that type of picture. This is what we say a vector data, we will come to that what is there. So, vector data, this is a raster representation of the data, same real world raster. So, this raster is as if putting a graph paper on the things and then coloring that this is this, this is this, this is this, right, or labeling, giving a number 10 is water body, number 4 is this, giving a digital number to the things. So, sometimes we say DN values to the things. Raster is more represented by what the argument, if it is a 2D space, we say that three things can represent all objects, like a point, a line or polyline, a polygon, right. So, it represents the things. So, instead of doing all these things, that if this the number is 3333, I say that this is a polygon of feature this grassland, right. This is a polygon of lake, this is a polygon of marshy land and type of things, right. So, different advantages are there for different type of applications. So, both raster and vector type of things. So, as we are taking, there is a representation representing spatial element. This is the raster representation, stored images as rows and columns, as we the direct example is the graph paper with a digital value or number, right. So, this yellow is 4, green is 5, red is 1 and type of thing. So, it distinguishes. Units are usually represented as square grid that are uniform in size, that is the standard representation. It can be variable grid, not square, rectangle, etc. Will as of now, it thinks of a square grid and type of things. Data is classified as continuous, that is a continuous tone of data, such as in an image. When we take a photograph, it is more of a raster, right. It is a continuous tone of data. We even take a photograph of a natural image, it is a continuous tone of the data, or sometimes called a thematic, where each cell denotes a feature type, right. I can say thematic layers. I say I for a particular theme, I say soil layer of IIT Kharagpur is a thematic layer, if the theme is soil. I say that overall say land use land cover or road network, that is a transportation network, it is a thematic layer. I say build up one layer, it is a thematic layer, where the buildings are there and type of things. So, it is a themes, and there can be numerous data format, TIFF, GIF, some type of things which are open source. There can be some proprietary formats also. And if this is the particular image, so we say that is a photograph. So, this is a raster image, characterize continuous data, rainfall, land surface temperature, represent data as a pixel grid, where each data cells are feature capable of retaining the properties and attribute, like we have seen this one, right, each pixel, or this square we say each pixel grids, right. And so, in the real world I can represent by this blue, green, this can have a values and type of things. On the other hand, in case of vector, we represent by these things. Instead of storing every row and column, we store this particular polygon as this one, this polygon as this one, and so forth, right. So, this is in case of a vector data set. So, in other sense, say I want to store this line, I store this 0.1, 0.2, this point, 0.4, these xy coordinates, right. If it is on the earth surface, the best known xy coordinates, what we know, we have learned from the school days, is the lat long, right. I can have other representation. If a graph paper, we say 3, 4, 3.4 and 4.4, and if based on the granularity, right. So, allows user to specify spatial location and assume that the geographic space is continuous, not broken up into discrete grid square, right. Stores feature as a set of xy coordinates. So, it is a series of, in a polygon, I say there is a series of xy, where the starting xy and the ending xy are same, right. In a polyline, it is again a series of xy point. If a point, only one xy point. So, what is argued that in a vector representation, if we can represent point, polygon and polyline, we can represent any object. So, these are two representations like vector data set, same data. If you just see how we represented here, this same data set, if it is in the vector, it is represented by this. So, as we are discussing, so there are represent objects by points, simplest of the element, lines or arcs or polylines, and polygon set of this. These three elements can be used to represent real world feature and attach location information. I say this line is a IIT street road, this point is a ATM, this polygon is a water body. So, this is a attribute can be attached. So, that is the role of attributes in a raster data model. The cell value region is an attribute which can attach to other files, brightness, land cover, etc. For vector data, attribute records linked to the point, polyline and polygon can store simple attributes as feature. Vector are linked to attributes of unique feature number, and we can say that these are the different attribute representation, right. So, this attribute, this polygon is polygon number 3, which is zone A4 with some zip code, right. So, I have a separate table which is attribute data, right, which is linked with this spatial representation. So, we will see that how. So, this way we try to link the things. This is another aspects which we will cover at somewhere end of the course is the visualization. How do I visualize this data? So, one visualization is this is taken from internet. So, so we can have this data with the different type of visualization. You can say that I want to visualize the digital terrain model. It is a 3D model of the things. The same region I can visualize of the digital terrain model. So, it depends that what is the use of the data, right. How do I use the data, right. And we will deal in different aspects. I thought that in the introduction there is it will be good to mention. So, there is a concept of now more spatial informatics or is more what we say looked as a spatial data science, right. So, there are arguments whether the same thing etcetera, but we are not going to those means classes or arguments, but we would like to see it in the it is a more of a data science problem, right. It is a multidisciplinary problem where we require definitely computer science, spatial statistics, machine learning, spatial data mining. So, these are all CS related stuff. Along with that, which is missing here, we require a domain expert. A transportation problem has to be handled by a transportation person, right, a soil by a soil scientist. So, the domain expert needs to be embedded into the things to get a meaningful into information into things. So, in this course may not be able to deal with all the aspects, but we will try to look at some of these things which helps us in how this multidisciplinary aspects can help in solving several problems which is related to or several challenges related to our day to day issues. So, finally, what again coming to that picture back. So, this is our integrated data. We have different type of layers, right, and we can take one or more layer for managing analyzing the data. So, data management, accessibility, analysis, mining, prediction, learning and which need to be there. And if you will go gradually, but you understand that this data set has a little bit or some a behavioral different behavior than our normal standard vanilla data sets what we deal with, right. So, how say even how do I say that a two polygon touching each other, what is the definition of overlap, right. Overlapping one student with one student data set with another data set has what meaning has to be looked into, but here that how to polygon overlap, whether this road is overlapping with something. So, there are different aspects of things what we will see. So, there are different topological relationship etcetera, which come into play where we require this sort of handling of these data sets. So, what we see here, this is a other way around. So, if I have the separate layers etcetera, then I can make this integrated data, right. Or in other sense, if I have different layers and take a decent things like I want a prediction model, if I have a spatio-temporal data set, I predict the some aspects etcetera, then I want to look at to see the down the line 10 years, 20 years down the line, how this overall IIT campus is likely to be there. There are a lot of ifs and buts into the things, but I can do a trend analysis and type of things looking at the different aspects. These are being extensively used for meteorological data sets with looking at different aspects of climate change phenomena, and several mechanisms, right. In as before ending today's talk, so what we are in this course, we try to look at this different aspect, like as we mentioned in the beginning, how to model this data, what are spatial database, what are the query problems, whether there is a special aspects of some of the things, like whether if I say that spatial networks, whether there is a special aspects or special dealing for that, how to mine this data and how to disseminate this data, how people can use this data, whether the spatial web services, even we will, if time permits, we will look at the spatial clouds and type of things, how this data can be harvested and can be used at by different domain and by different domain experts. So, with this, let me conclude today's talk and we will continue in our next lecture. Thank you.